Parker BAS HL breathing air system. In most countries, legislation demands employers provide protection for their employees. This includes when working in the presence of substances that can be damaging to health, and those employees working in hazardous environments. Anyone working in such environments must be provided with adequate personal protective equipment, abbreviated to PPE. Equipment to protect the lungs is known as respiratory protective equipment, or RPE. EN 529/2005 is a European Union standard document providing recommendations for selection, use, care and maintenance of respiratory protective equipment. It states that there are two distinct types of respiratory protective devices: filtering devices and breathing apparatus. Filtering devices. Filtering devices include respirators and face masks that purify ambient air by inhaling it through a medium which removes the contaminants. Filtering devices must be matched to the substances from which the wearer needs protection. However, they typically only protect against limited concentration of contaminants. Filter-based RPE is not suitable for all applications, especially in the presence of dangerous gases or in an oxygen-deficient environment. Breathing apparatus. Breathing apparatus is the term used to describe the devices that supply breathable air or breathable gas from an uncontaminated source. For example, compressed air or compressed oxygen. The use of high-pressure self-contained breathing apparatus is expensive, can be dangerous, and requires highly trained personnel. Therefore, for most industrial applications, compressed air-fed breathing apparatus is a more cost-effective solution, as this provides a continuous source of breathable quality air from a compressed air supply. Unfortunately, it's not just a case of connecting breathing apparatus into a standard compressed air line. Compressed air contains contamination and must therefore be treated before it becomes suitable for breathing. For typical industrial applications, there are a minimum of 10 contaminants found in compressed air that must be treated. These originate from 4 different sources. However, for breathable quality compressed air, there are a minimum of 15 contaminants that must be treated. Global standards for breathable quality compressed air. There are strict standards and guidelines globally governing the quality of compressed air feeding breathing apparatus. Compliance is usually mandatory and enforceable by law. For the European Union and United Kingdom, EN 12021 typically applies to industrial applications, as recommended by EN 529/2005, and European Pharmacopoeia typically applies to medical applications. For the United States of America, OSHA Grade D applies, and for Canada, CSAZ 180.1. It is important to note that the maximum contaminant levels allowed differs in each standard, and these standards do not have limits for all of the common compressed air contaminants. These missing contaminants are still hazardous and require treatment if compressed air is to supply breathing apparatus. Introducing the Parker BAS HL, a complete purification system for breathable quality compressed air. The many contaminants found in compressed air are present in different phases and require several different purification technologies for their treatment. These purification technologies are typically supplied separately, and components can often be incorrectly specified or completely missed from an installation. Inadequate purification can lead to hazardous contaminants being inhaled by the user, with potentially serious consequences. The Parker design philosophy is to supply a complete purification system that treats the most hazardous contaminants found in a standard compressed air system. All of the purification technologies required to provide breathable quality compressed air are therefore packaged into a single breathing air purification system, the BAS HL. Having a complete purification system simplifies equipment selection, helps to guarantee compressed air purity, and allows the BAS HL to be tested and third-party performance validated as a complete package. The delivered air quality from a Parker BAS HL breathing air system meets and exceeds the requirements of global breathing air standards such as EN 12021, European Pharmacopoeia, OSHA Grade D and CSAZ 180.1. The Parker BAS HL range consists of 8 models with flow rates from 55 to 300 cubic meters per hour or 32 to 177 cubic feet per minute. Each model includes all of the purification technologies required for the treatment of 13 hazardous compressed air contaminants. The number of contaminants treated can be increased to 15, with the inclusion of an optional WS-grade water separator, should liquid water or liquid oil also be present at the inlet of the BAS HL breathing air system. BAS HL, how it works. To provide breathable quality compressed air, the BAS HL breathing air system uses 7 distinct purification stages consisting of different purification technologies, each of which is targeting the reduction of specific contaminants. The purification stages are made up of Stage 1, a general-purpose coalescing filter. Stage 2, a high-efficiency coalescing filter. Stage 3, an adsorption dryer. Stage 4, an adsorption filter. Stage 5, a catalyst stage. Stage 6, a general-purpose dry particulate filter. Stage 7, a high-efficiency dry particulate filter. Stage 1 is for the reduction of water and oil aerosols down to 0.5 milligrams per cubic meter, or 0.5 parts per million, and particulate reduction down to 1 micron. Stage 2 is for the reduction of water and oil aerosols down to 0.01 milligrams per cubic meter, or 0.01 parts per million, and particulate reduction down to 0.01 micron. Stages 1 and 2 not only reduce hazardous contaminants from the compressed air, but they also provide protection for the adsorption dryer. Stage 3 is for the reduction of water vapor and is designed to deliver a constant pressure dew point of less than -40 degrees Celsius. The selection of a pressure dew point lower than -40 degrees Celsius is very important for 2 reasons. Firstly, a low dew point is required to protect the catalyst stage. Without very dry air, the catalyst can be poisoned with water vapor and will no longer treat any carbon monoxide present in the compressed air. Secondly, the low dew point is also used to control the growth of microorganisms in the downstream compressed air. Untreated compressed air contains millions of microorganisms that are constantly growing. Sampling of a typical compressor airline clearly shows the presence of microorganisms in untreated compressed air. A dew point lower than -40 degrees Celsius has been proven to inhibit the growth of microorganisms. Reducing the quantity of microorganisms present also improves the reduction performance of final filters. Stage 3 provides another important function. It is also used to reduce carbon dioxide levels to less than 500 parts per million. Stage 4 is for the reduction of oil vapor to less than 0.003 milligrams per cubic meter, or 0.003 parts per million, nitrogen oxide to less than 2 parts per million, nitrogen dioxide to less than 2 parts per million, and sulfur dioxide to less than 1 part per million. Stage 5 is for the reduction of carbon monoxide to less than 5 parts per million. Carbon monoxide is converted into carbon dioxide by the catalyst stage. Stage 6 is for the reduction of particles of adsorbent material down to 1 micron. Stage 7 is the final stage and is used for the reduction of adsorbent particles and microorganisms down to 0.01 micron at an efficiency of 99.9999%. Parker BAS HL features include integrated filtration, easy-to-change cartridges for desiccant, carbon and catalyst stages, electronic control system, including purge economy energy saving, dew point hygrometer, complete with a 4 to 20 mA dew point retransmission capability, real-time dew point display, remote start-stop, Modbus RTU connectivity, fault alarm relay. The BAS HL range has been tested in accordance with 8 international standards. Outlet air quality of BAS-HL has been independently validated by Lloyd's Register as ISO 8573-1, Class 120, and shown to exceed the requirements of EN 12021, European Pharmacopoeia, OSHA Grade D, and CSAZ 180.1, International Breathing Air Standards. BAS-HL, a complete solution to breathable quality compressed air.